Hi, everyone. So in this lab, we're going to go over XRF analysis. We're going to start with two samples. We're not really sure if these samples are the same. We want to test this. They look the same, but we don't know. And we're going to use XRF to determine if they have the same assay. But what is XRF? Let's go over that. Well, this gun has two components that we're going to talk about. The first is the source, the X-ray source. The second is an X-ray detector. And I'm going to put our sample somewhere here. The source emits an X-ray, which is absorbed by an atom in the sample. And then the atom, after absorbing the first X-ray, emits a second one, which is detected. And the energy of this emitted X-ray will tell us the elemental composition of our sample. Now, importantly, the first X-ray emitted from the source does not penetrate the whole sample. So this sample has to be homogeneous when we set it up for XRF analysis, or we're not going to get accurate results. And that's what we need to keep in mind when preparing samples for this lab. An obvious way to ensure homogeneity is to reduce the particle size. So first, we're going to screen at 30 mesh, and therefore we're dealing just with small particles, higher liberation factors. Then we're going to make particles even smaller, putting one of the samples in a mortar and pestle, and we're going to grind it up so that we get tiny particles that are easy to analyze. And this can take a while, so let's speed this up. Next, we have to take our homogenized sample and prepare it for analysis. We don't want to get the instrument dirty, so we're going to put each sample in one of these cups. And this thin film you see me handling is going to be the only barrier between the XRF gun and the sample, while the cup will hold everything and make it easy to transport. The thin film is held in place by this ring, as you can see. It's not easy to do. We need to make sure the film is flat and doesn't break, and you need to make sure you're installing everything correctly. For each of our two samples, we're going to analyze the sample 5 times. So let's just repeat this again real quick. Put that film into the ring and over the cup, making sure the film isn't wrinkled. Pushing it down carefully, wiping off any excess debris. Then each cup is filled with the sample. Doesn't need to be filled exactly to the brim, but enough for analysis. And a cap is placed on the back. And that's what it looks like. After emptying the first sample from the mortar and pestle, we put the second one in and grind it so that we can make it more homogeneous to get a better analysis. For the second sample set, we're going to make pellets to see if that makes any difference. So in order to do so, we need to take an assembly and fill it with a small amount of sample and then compress it. The weight for each pellet is about 4 grams. So 4 grams of sample is added to the piston assembly, and it doesn't need to be perfect, just about 4 grams. You don't want too little, or else there's going to be nothing there, and you don't want too much, because that's going to make it hard to compress. The jack in the right corner is used to compress the piston assembly enough to hopefully get a pellet to stay together. And here's our pellets. As you can see, none of them are perfect, but they're all big enough. They have trouble fitting into the cups, so we need to break them anyway. And we're going to do so in a way where we don't get too much dust in there. Obviously, we can't be perfect, but try and get a good chunk in there so that the XRF gun can get an accurate reading. And this was repeated 4 more times, so that for this sample set we have 5 samples total, and the other sample set we have 5 samples, and this gives us 10 samples. Next, all of our samples are brought over to our XRF machine. It's connected to a computer to make it easier to read out the data, and you can also see it's connected to a stand. The purpose of the stand is to ensure safe operation. Believe it or not, some people will scan a sample while holding it in their hand or while it's on their thigh. While the dose of radiation an individual would receive from doing this once would not be life-threatening, it's just not a good practice. Once the scan starts, lights on both the XRF gun and the computer indicate the X-ray source is on, and that a radiation hazard is present. A scan using the settings appropriate for this lab takes about 1.5 minutes. The first scan is done, and the results are available both on the gun and the computer. We've got 9 more to do, but I'll speed things up.